note that as we go through 2.5, I decided to add in just a few, not everything that the book has, because some of those we're going to get into when we get into chapter 3 anyways, and then we revisit the same thing again when we get to chapter 7. And so I added a few types of problems to this section, and I sent them as a separate PDF because in my original PDF of the kind of outline of chapter 2 notes, I hadn't typed that in yet. So my apologies. I thought it was better to give you more variety than less variety in case you came upon something and you were like, hey, my teacher never showed me an example like that. So sometimes more is better. And I've typed them all out for you, and it's marked 2.5 additional examples. And after the video, I will load that up to Canvas as well. So this section, like I said, is problem solving, application questions. The first one we're going to look at is percent increase or decrease. I really, really like this skill. I use this all the time when I shop. As prices go up, or your salary goes up or down, or your insurance goes up or down, and I think to myself, what percent did it go up? How much are they really getting when they raise this? You see down here I have this Netflix example. And so even though we might think, oh, something at a store might just go up a little bit, but percentage-wise, when you think of that, and inflation and whatnot, it goes up quite a bit. So the idea behind percent increase and decrease is that it is the new, whatever the newest number is in time minus the original number. And then we need to make sure that we have that in parentheses divided by the original number. So when you type this in your calculator, you either want to type in this piece and then hit the equal sign before you divide, or you want to type that in with a set of parentheses. Otherwise, you are telling your calculator just to divide this back number. And so you're always going to get just the new number minus 1, because the original over the original would just be equal to 1. So just a word of caution there. All right, Gabby recently lost weight. She originally weighed 175, and now she weighs 150. So 150 is the newest weight, minus 175. The original weight was 175. So what percent decrease can we expect to see here, or was this situation? It is going to be a negative number because it went down and not up. And so when I plug this into my calculator, I get negative 0.1428, and then that decimal keeps on going. So I'm going to round to the nearest tenth. So I'm going to move this over 2 times to make it a percent. So I'm going to get minus 14.28%. And then I'm going to look at that 8 because I want to round to this one right here. So the 8 is what I'm going to look at. 8 is 5 or larger. So my final answer here I'm going to write as minus 14.3% of her body weight. Let's look at Netflix. I can't remember exactly, well, that came out kind of funny. Netflix. All right. I can't remember exactly what the rates were when Netflix first came out. I feel like it was right around $7.99 a month. And now they're talking, I've heard rumors that it's going up again, but I think it's right around here. So if I'm off a little bit, please forgive me. But the now is $14.99 minus the original price was $7.99 over $7.99. And we think, gosh, it only went up $7, $7 a month. That's not much. But when I place this in my calculator, I get 0.876. And so when I 8760. So when I move this over twice, that is an 87.6% hike. And then you might compare that to like the raise you got. Did you get an 87% raise? No, you did not, probably, most of us. And so that's a nice little raise Netflix gave themselves. All right, so if you want to stop and try. The original price is $325. The price now is $250. It should be negative because Matt got it on sale. And so this is our setup here. The new minus the original over the original. So, and then again, put that in parentheses. And so it would be negative 75 over 325. And so you should have gotten a negative 0.2307. So when I move this twice, I get 23.07. So I'm going to round that to the nearest tenth. So negative 23.1%. So I find percent increases and decreases super helpful. Let's move on to a couple of different types. So I stuck with the geometry examples. The next one is going to be the perimeter of a rectangle. So I know that on your notes you don't have this fancy triangle situation, but I would sketch something just for the purpose of writing in so that you can kind of see the visual. So it doesn't matter which angle you call the first, second, and oh gosh, this is rectangle. Not the next one is triangle. Oopsie. All right, let me fix that. You're probably like, what is she doing? All right, let's make a rectangle, shall we? Let's do that. Here we go. All right, so here's our perimeter. Here's our rectangle. If you've forgotten, perimeter means the distance around. So in general, we think of that as this length plus this width plus this length plus this width. Because if you were going to travel all the way around your rectangle, that's what you would have. That's how far you would walk. And so if you were to write a formula down, perimeter would be 2 widths or 2 lengths plus 2 widths, 2 of each. All right, the perimeter of the basketball court is 288. They're telling us what this number is right here, 288 feet. So I'm going to plug that 288 in right here. The length is 44 feet longer than the width. The length is 44 feet longer than the width. So over here off to the side, you can express the length a little bit differently because we know it's 44 feet longer. I gave you a try that's a less than. Just a word of caution, the less than part goes in the back. So we'll see, I kind of challenged you on the try here. And so the 2W, that's not going to change. Plus the 2. And so instead of writing the length, I'm going to express it all in the same variable. I'm going to use that right here. And a little bit, this is before we get into substitution, elimination, and 2 variables, but this is very similar to some things that you would do in that chapter as well. All right, so now everything is just in W. I am going to distribute this next. So I'm going to have 288 equals 2W, this part coming straight down, plus this 2W, plus 2 times 44 is 88. Just to save room, I'm going to do 2 steps in one. I'm going to take that over to the other side because I know that needs to move over. And when I draw my line, I know that these 2 pieces are like terms. So 288 minus 88 is 200. And then 2w plus 2w is 4w. Divide both sides by 4. And the width is equal to 50 feet. And notice how I circled this up here, because if I need to find the dimensions, I also need to find the length. And I've got it circled. If the width is 50, and I put that right there, 50 plus 44 means the length has to be 94 feet. So super similar. You can try one here. You don't really even need a picture to do the rectangle ones. The formula is exactly the same. If you prefer, you can even write it like this. And so that perimeter is on the right-hand side. And then if you want to try what this would look like, and I'll just pause real quick. And it says the width is 60 less than the length. You have to put the length first. Or you have to write it as negative 60 plus L. All right, so let's plug everything in. The perimeter is 520. So as I go through, this is going to change to a 520. I've got W that I am substituting in for at this point. So everything is going to be in terms of the length. And so W is L minus 60 plus 2L equals 520. Multiply through by 2. So I get 2L minus 60 plus 2L equals 520. These are like terms. So now I have 4L minus 60 equals 520. Add the 60 to both sides. 4L is going to be 580. And so L is going to be 145. And I still need to find that width. But again, up here, let's go back to what I've circled. If I plug in 145 for the length right here, 145 subtract 60 is 85. And these are in feet. Okay, now let's do the triangle one. Sorry, I goofed on that other piece. I got a little excited to use my triangle draw feature here. All right, so it doesn't matter which angle is which. That's what I was saying before. So, you know, this can be the first angle. Let's put it in red. This can be the first. This can be the second. This can be the third. A fact of geometry is that the sum of the angles of a triangle add up to 180. So what we're going to do is we're going to kind of write in a little expression for each angle inside this triangle, and then we're just going to add up our three pieces, and then it's going to equal 180. So these are not as hard as they might appear to be at first glance. All right, the second angle of a triangle is 3 times as large as the first. So this one is 3 times bigger. So let's just make this x and see if that doesn't help us. Let's just call that first one x, because then this one would be expressed as 3x. And then let's keep reading and see if it tells us a hint for that last one. The third angle is 30 degrees more than the first. Well, the first is x, so this could be expressed as x plus 30. So one of your 3 angles, when you try these, one of them has to just be plain old x. And then we're just going to write a really long expression, x plus 3x plus x plus 30. And then we're going to set that equal to 180. So 1 plus 3 is 4, plus 1 more is 5. I have 5x plus 30 equals 180. Take that 30 to the other side. So 5x equals 150. Divide by 5, divide by 5. X equals 30. So I need to find all three angles. Find all the angles. So I need to go back in and substitute it back in. And so this is just x. So this one would have a measurement of 30. 3 times x. Granted, my triangle is not to scale because I did not know. So clearly a 90-degree angle looks more like that. This one, 3 times 30, this one would be 90. And then x plus 30, 30 plus 30 is 60. And you can write that in numerical 30, 60, 90. That's actually, if you're a builder of any type, that's actually a pretty common type of special triangle. And so my picture was not to scale. All right, if you guys want to pause and try. Says the third angle is twice as big as the second. So let's make that second x, see if that doesn't help us. And so it says the third one is twice as big. And the first one is 20 degrees more than the second. So x plus 20. I don't know if the red ink really does nicely here, so let's change it back. X plus 20 plus x plus 2x. And all triangles add up to 180. So 1 plus 1 plus 2 is 4x plus 20. Take the 20 to the other side. And then we're going to divide by 4. So x is 40. And then when we plug it back in, we're going to put a 40 here, a 40 here, and a 40 here. So this angle will be 60. This angle will be 40. And this angle will be 80. 2 times 40 is 80. So these are my three angles. Do they indeed add up to 180? Yes, they do. All right. So there's just a few of the types of word problems we could do in math. By no means did I do an example of all of them. I will try for the most part to match the homework and the test questions to the ones I put in the notes. It is always my goal to be consistent in that way. Or I end up marking it as extra credit. So, all right, so that is the end of this video, and then we go into inequalities, and I will put that on a separate one. So take care, everybody. I hope you are successful.